Peter, we're live, I believe. Or it's
I
going
still
live.
see.
There we go. I believe we are here.
All right. Hello, everyone. And thanks for bearing with us while we were sorting out some tech issues behind the scenes. Welcome to our Firebase After Hours live stream. We've got an exciting topic today, and I've got two more people waiting in the lobby. And before we put them on, I wanted to quickly go through our code of conduct. It's really quite easy. Let's be excellent to each other. So, let's talk about the good things. If there is something that you don't like, you can tell us in polite terms. If there is something that you do like, let us know. You can use the chat to talk with us. We'll be monitoring the chat. And if you've got any questions, put them in the live chat, and we will pick them up and get them answered. So we've got one subject matter expert today with us. With that, let's get started.
Woohoo! I think,
Okay, hey,
take
folks.
two.
Yes. All right. Hey, Pavel, how's it going?
Hi. Yeah, like finally we're live. Only had to
Yeah,
reboot once.
I can see us. All right, amazing. Cool. Yeah, so today we want to talk about Genkit, but before we get into that, I wanted to quickly, see what everybody's programming language is to, warm us up. So I'll start. I've done a bunch of programming languages in the past. I think the first one I did was BASIC, then I did Delphi, the most I think my favorite one is Swift. So now, working on Genkit a little bit myself, I find it a little bit challenging to always have the concepts in my mind, like how does this work in Swift, and then trying to write TypeScript code and not getting yelled at by the compiler too much. But it's getting there. How about you, Pavel?
Yeah, I guess I kind of I worked with so many languages kind of lately. I've been switching back and forth. So I'm really kind of my favorite language is probably the one that I worked the most with recently. So again, I started off with Java, and I love Java, but I worked a ton with JavaScript, TypeScript, and then I really became a fan of Dart because it's kind of a JavaScript, but way better. And I worked with Go, and yeah, and now kind of with Firebase Genkit, it's been TypeScript and Go, and those are, I guess, my favorite languages at the moment.
Oh, well, that's good luck for you. How about you, Noe? I think you really like Go, but is it your favorite language?
It's the language I use the most outside of work. I've never written it professionally for like money, right? But I just always do it for fun. And it's if I'm going to build something new, I grab Go off the shelf, right?
Mm-hmm.
Uh, yeah, and that's pretty much my favorite language.
Well, and then I guess that is also a very good coincidence because you can use Go with Genkit as well. So both TypeScript and Go, if I remember correctly. So why don't we get into it? Pavel, you are, oh, well, tell us who you are, and then what you do on Genkit, and then let's get into what Genkit is and what you can use it for.
Oh yeah, I guess I'm the technical lead for Firebase Genkit. Kind of uh, was there from the beginning. So I guess like and that we have a really amazing team working on Genkit. So like as I say, like if you like something about Genkit, it's the kind of the achievement of our amazing team. Like if you don't like something, like blame me because I'm the one responsible for that. But yeah, So yeah, and speaking of Go, like it is launching soon, so it is not quite yet available, but it is like the nice thing about Genkit, it's all open source. You can go see the progress on GitHub, follow along, and try things out. So
yeah, that's very cool. All right, so what is Genkit and what can you do with it?
right, yeah. So Firebase Genkit is an open source Gen AI integration framework. Always challenging to kind of come up with a good one-liner to describe a framework, but that's why we're here, and we're just gonna go through all of these different features that Genkit offers, and we're gonna deep dive into a few of them here. So yeah, like I'll go over some of the high level features. The most kind of important feature of Genkit is a really convenient model abstraction. So we have have a consistent interface for all the models that work with Genkit, and we have a a plugin system that allows you to implement arbitrary models and provide access through Genkit APIs. So like for example, here we have an example, showing that you can swap out models pretty much on the fly. Like you flip a coin and you either use Gemini Pro or Ollama or Gemma through Ollama. So this kind of shows that this is kind of a, you want to try a different model, no problem. Just just swap it out here. We support structured output out of the box. We rely on Zod for defining schemas, and then you can tell them the model to generate output in a specific JSON format, and you're just basically getting the JSON object instead of a text output if you really need to. We fully multimodal and support multimedia, including like images and video for for models that do support it. So like here we have an example using the Imagine model to generate images, and we're probably gonna take a look at how that works in reality here in a second. You can work with tools for building agents, function calling, and all that stuff is really easy to implement. Like you define a tool, and then you just say model, you have access to these tools, and off you go. Genkit comes with a prompt management library, so you can there's a very convenient way to define prompts in a separate file if you want to. This makes it really convenient to like collaborate on prompts, and just keeping them separate from your code, because sometimes you really want to. Genkit has a concept of flows, which we're going to be deep diving into, which allows you to kind of encapsulate your logic and work with it through Genkit tooling. And here we see a little demo of the Genkit Dev UI, which we'll be looking at a lot. It is a really cool feature. So through there, full observability, you can trace pretty much anything with Genkit, and you can see details of execution and play around with various inputs, and of course it's an open source framework, but it's not just open source. Like we try to leverage a lot of the open standards, and like through our plugin system, you can extend Genkit as much as you want. And like for observability, for like tracing, we rely on open telemetry a lot. So you can plug in any observability frameworks if you want. And of course, like it is built for production. So Genkit is built for app developers who build and deploy their apps, and we really want to make it very easy to run your app in production. So a lot of production grade features for especially for observability. Like here, see in the screenshot, we're also going to be seeing some live samples of tracing, and security and authorization is all built in. So You can define custom auth policies and all that stuff, which is like very, very important when you're building production apps. So yeah, and that's open source, and we support a whole bunch of models, and right now, yeah, we're probably going to take a look, but like we have a lot of third-party community plugins built for various third-party models. So Genkit is not only for Google models and products. It is open. There's a lot of plugins available for third-party products and models and APIs.
So, Pavel, we actually have a question from the chat that I wanted to ask a little early. So one of the first questions that we got was, what is the difference between Vertex AI and Genkit? So could you walk us through how Vertex AI is an integration, and what's the difference, and when would you choose one over the other?
Yeah, so Vertex AI is a Google Cloud sort of umbrella product that provides a whole bunch of things, but so actually here we can see that the Vertex AI is one of our plugins, and Vertex AI provides access to models and other services. Like for example, models you can run Gemini, Pro, Provision, Flash, 1.5 Pro, Imagine, and also some third-party models, like for example the Anthropic Claude through Vertex Model Garden, and Genkit works with Vertex AI, and basically like Genkit is an integration framework. So we allow like you would build your app with Genkit, and your app will work with Vertex models and other APIs. So yeah, they're kind of Genkit uses Vertex, and Genkit is to help you write the actual app. That is kind of the difference.
So it's not like an either or scenario, right? It's like one with the other.
Oh yeah. Like yeah, if you're using Vertex AI, like you still need some kind of you still use some kind of a framework to integrate all these things into your app, and Genkit is what we offer.
So maybe along the same lines, I assume some people might be wondering, so why would I want to use a framework like Genkit in the first place if I can directly call a model from my mobile app, for example? So I mean, you can directly call Gemini from your Android, iOS, or web application, and that's probably all good, and just what you need for many use cases. So what are some of the reasons why you might want to choose Genkit over just directly talking to a model?
Yeah, this is a very good question, and yeah, and Firebase offers I don't remember the full name, the Vertex AI client SDKs for Android and iOS. Mm-hmm. So for example, yeah, you can totally use those right in the app, and some simpler cases are totally fine with that, but often you need access to like some private data that is in the database, right? So you need to massage it in a way. Maybe you need access to other APIs that are just like not built to be accessed directly from the client. So you would often like the way you would kind of work around this is you would build a backend where you would have access to all of these, or like all of that data in a safe way. All of those, maybe APIs. Maybe you have an existing API somewhere that you can, retrieve data, or you want to integrate with as you're doing some Gen AI feature. So, like you would build that in the back end, and these more complex, more advanced, not necessarily advanced, but like anytime you kind of get into some kind of integration, you do it on the back end, and it's easier to do this with a framework. So one of the things is that we often see with with GenAI as we're getting feedback, as we're building the framework, and we were talking to people who were trying to build their apps with GenAI, is using using models. Like models are non-deterministic, right? So there's often your typical app developer frame of mind, where you just you call a function and it returns a a result that you expect. Doesn't quite work when you're doing Gen AI development. So you need a couple of extra tools to help you with dealing with this uncertainty in responses and non-deterministic nature of LLMs. So, and Genkit has offers a lot of that tooling. That just it doesn't mean that you can't build an app without a framework. You totally can, but it's just like we make it just way easier for you to do.
Yeah, so there was another question on the stream here. Somebody asked, can we use our own APIs? And I guess that that means a lot of things, right? So maybe I'll put my understanding of the question here. So can we, let's say I've got an application and I've got some backend APIs that I want to call. I don't know, for example, I've got some billing API I want to call, or a database I want to tap into. Is that something that I can do in Genkit?
It's a great question, and maybe like we can use this as a segue to dive into some of the features of Genkit, and maybe we'll start with looking at flows, and I'll talk about like how you can do whatever you want with flows.
Yeah, tell me the code.
Okay, let's look at the code. So this is the code. So I guess. I wasn't prepared to start exactly at this point, but so with Genkit, so as we mentioned, we have flows, and flows is just basically a way for you to encapsulate your logic into this, into it like so. It is a function basically, right? So like a flow is a function that just has a bunch of extra features, right? So for example, like it has observability, validation, and tooling integration, and flows can be as simple and trivial or as complex as you really want, right? So here we have an example of a flow that just basically it's a function. We call it a style generator, and it just basically iterates over a couple of arrays and just generates us generates an array. A good example of a function, and we can go into, so you would typically do Genkit start with your code, and it would start a dev UI, and we can go to the dev UI, and here we see our style generator flow, and we just run this, and it just outputs an array. Right, so there's a very simple function. So we can do like pretty much anything in here. So within the body of the flow, you can put arbitrary code, and as you're running these flows, they're getting fully traced. So we actually getting tracing for this. There's nothing happening on the inside, but you're still getting tracing. And one other thing that we can do is we can stream data from here. So like, for example, as we're iterating over these arrays, we're gonna go and stream the style as we're actually, we have to do if streaming callback is defined. I guess sorry. No, yeah. So if streaming callback is defined, we're just going to stream our styles from there, and we can go and and stream. And we run it in the streaming mode, and we see that we're streaming these styles in the beginning, and then we just get the response. So this is I'm showing a flow that generates restaurant styles that we're going to be looking at later. So this is very very simple, but this shows that a flow is a simple function. And here we can take a look at a more advanced flow. Here we have a restaurant generator, right? So we're defining this flow. It's a restaurant generator, and we're saying that we're accepting a string input, which is going to be the theme. So it's basically one of these, like the style, right? So this is and then this is comes in as a theme, and and the output is going to be a restaurant that we're just going to generate. So and here we can look at the schema, and we're using Zod here to define the schema, and it's basically it has a name, it has a description, the cost range, and the type. And here within our flow, we do a little bit more here. So here we would call a model. So here we're going to be calling Gemini 1.5 Flash using our generate function, and we're going to be saying generate a restaurant with the following theme that we accepted as input, and we're giving some additional instructions to come up with clever names. And in here, we're actually saying to the LLM as well, use the schema. So actually return a JSON object. Don't return text. I want a JSON object, and the temperature one. We want creative outputs, and here we get the restaurant. And as the next step, we're actually gonna use the Imagine model, and we're gonna say, generate a professional-looking photo for the following restaurant, and blah, 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 some additional instructions, and this is the restaurant name and the description. So in here, we're just going to get a photo generated for our restaurant. And then we're going to, the photos are kind of big. I actually want to write them to Firestore. I'm going to actually resize the image here to a smaller size. And then I'm going to write it to Firestore into the restaurants collection. And I'm going to also add embeddings to it, which we're going to look at RAG a little later. But going to generate embeddings, and here's our photo URL, and then the flow returns a restaurant. So much more interesting, right? So and we go to our restaurant generator, and let's say, I don't know, banana. We're going to generate a banana-themed restaurant. Let's see if it's going to manage to generate us a banana-themed restaurant. It takes a second because there's several LLM calls. And here we see the name of the restaurant is a yellow peel. And you see, this is actually, a JSON object that we get. And this is the description that it came up with. It's a vibrant and playful restaurant that celebrates all things banana. Awesome, perfect, right? So we have a cost. It's in the middle. It's casual dining. And from here,
what about the image though? Didn't you also generate an image?
Yes. So I did not return it from the flow, but I wrote it to Firestore. And let's take a look. So here, we're looking at the trace for our restaurant generator, and we can see here was our first call to the model, and in here we see that we're output should be JSON and all that, like all those instructions, and we have the JSON schema that get automatically generated from our Zod schema, and here we see the JSON returned, and then we make the call to the Imagine model, and let's see what kind of image it generated. Oh, perfect.
I want to eat there. That looks amazing.
Yeah.
Oh my gosh.
Yeah, so this is our restaurant with the banana themed, which is pretty awesome. Yeah, and then we generated some embeddings, and we wrote it to Firestore. And actually, I think I have a few more generated here. Let's see. Let's see if we can load them all from. It takes a second. Okay, yeah. So here, I previously just went ahead and generated a whole bunch of restaurants, and you know, they're all kind of look pretty cool. We have and these are already resized images because like we're you know, downsizing them a little bit. And let's see if we can find our banana restaurant here.
And this is the output from the LLM being written to Firestore, correct?
To Firestore, yeah.
Okay, cool.
So yeah, and I guess like to the here's our the yellow peel, our awesome restaurant. So yeah,
that sounds really appealing.
I mean, yeah, can't go without puns. So yeah, so like here we're just basically showing that this is our, you know, within this flow we just did a whole bunch of things. We just, you know, made a call to an LLM, and another call to another LLM that generated us an image, and then we wrote to Firestore. Like if you can, you know, make a call to an arbitrary like API through Node, you can just do it here as a step, right? So you can do whatever you want with flows.
Okay, so we could have used, we could have taken the photo, for example, and we could have stored it in cloud storage because that is capable of storing much larger images. And then we could have taken the path and stored that in Firestore.
Yes. Like don't store images in Firestore, put them in storage. But
yeah,
this is a you know, a lazy sample. Like do as I say, not as I do, kind of a situation.
I have, you know, before we go on, I've got a question. So if we look at that flow, it's got multiple steps. So one thing that I've always been wondering is like, when should you break something up into smaller pieces? You know, should those individual steps, like generating the restaurant description and generating the image, should these steps all be part of that larger flow, or should I factor them out into smaller flows? Is there like the one go-to answer, or does it depend?
Yeah, I guess it really depends. So I guess like the rule of thumb is that like if you can clearly define these units of work as like, you know, this is you know, this thing does this thing, and like and the other thing does the other thing, and then yeah, with flows you know, you can totally run flow from within another flow. So for example, like here we could do, you know, run flow, and for example, like down below we have our, you know, a style generator flow. We can say, you know, run this, and I guess it takes an undefined input, and we just await, and that's it, right? So so we can, you know, always run any flow from within another flow, or for that matter, from anywhere else, right? For example, you could have maybe a custom Express server in your code, or you're maybe using a you know, a Firestore triggered cloud function, or some kind of a pub sub triggered function, and from that, you know, if you want to run a flow, that's totally fine. So yeah, but I guess like, yeah, to your question, it depends. So but the nice thing is that, so when you where's our dev UI, right? So when you run these flows and you look at their traces, you see them kind of you know, showing up separately here on the left, and it makes it easier to maybe like debug and play around with things. So one of the interesting features that, for example, like we were looking at this restaurant generator, right? So we had input of banana, and we have this open in flow runner button, and we click, and it takes us to the back to our playground where we can run this again, right? Or like if we just look at this again, it doesn't have to be necessarily a flow. Here we can actually, as we're looking at the LLM step, we can just open that in the playground, and it's going to take us straight to the model playground. And from the model playground, you can just run this. and just basically replay just the actual LLM interaction. And here you can, like, if something doesn't look right, you can just maybe do some prompt engineering right in here. Like if you maybe some field needs a better descriptions, or you want to provide some samples, it is really really convenient. So as you're breaking up your code and into these logical blocks, it's just easier to play with them individually. And one thing to kind of to point out about tracing within Genkit. So when you're running things locally, like in like when you do Genkit start and you get this code, it is important to remember that this is actually running completely locally. So these traces are literally written to your disk, and like they're not getting written to, like, to the cloud, to any, like, a Firestore storage. Basically, they're getting written to your local machine, to disk. So there's actually, like, no cost to doing this tracing and looking at our traces, playing with things as you're developing. Like, well, I mean, obviously, running a model might cost you, like, if you're so that's a separate thing. But the local tracing and the whole development experience is fully local and basically doesn't cost you anything. So always like, look at these traces, and especially with when you're doing structured output. Often maybe, like, you would get some kind of a validation error because the LLM didn't generate a valid JSON for some reason. Like, go click on the modeled output and you will see the raw output here. So here we see that the LLM actually adds, like, the markdown for the JSON. Genkit handles things like that for you, so you don't have to worry about stripping out the markdown and things like that. But LLMs can get things wrong. So maybe, like, they set the wrong type on a field or something, like. So, and you'll get a validation error. Just go look at what did it do, and often you will see, well, maybe a better description or giving it examples of input is just going to be is going to help it to come up with a valid JSON.
Yeah, sorry.
Jinx.
No, go ahead.
Pavel, I have a question, and chat also has a question, but I'm going to ask it in my own way. I tend to write a lot of error-prone code. If I wanted to catch those errors in Genkit, could you show me how I would go about doing that, and maybe how to bail out successfully without crashing the flow?
I mean, so it's an interesting question, and I guess the answer is like, how would you do it in JavaScript? I mean, you would just write a try catch, yep. Right? So feel free to do that, and then you do catch, and there. This is your error handling. So you don't need to do kind of anything special. Well, I guess this variable is not defined anymore, but whatever. So yeah, you would do error handling however you would do it regularly.
Perfect. Thank you.
So if I don't handle the error, it will crash, I assume. So the flow crashes, and then what? Does it resume?
Yeah. So like, let me see if I have. I'm writing perfect code. Sorry, I never get errors. But
don't you all?
Code with infinite quota.
Yeah, I guess it's nice to work at Google because you get access to these models and you don't have to pay for them. But so yeah, I guess, yeah. So if you get an error, like the flow will throw an error, and you actually will see, well, maybe let's try and throw an error deliberately. Let's say if true, throw error, right? So this, when we had our what is that, restaurant generator, banana run, I guess, yeah, it'll
before the LLM call. Oh, there we go.
Okay, there. So yeah. So and here we can see that you see, like, the LLM called actually succeeded. That was fine, but the error was thrown there later. So you get the errors, and you can I think you can look at the terminal output here, and you see. Let's see. There's an error here as well. There's more details, but yeah. So there's kind of a full error handling within the flows.
Is that error returned back to the function call? So if I were to call this over the HTTP endpoint, would I still get that error?
Yes.
Context?
Yeah. So the deployed flows are using the callable function protocol for Firebase callable functions, and you would get the an error object back. So with all the details. Yeah.
But not all flows are exposed like that, right?
So not all of them, sorry, what do you mean not all are exposed like that?
I was trying to get at that you need to specifically say, I want to expose a flow as a callable function.
Oh, yes. So with when you're building for Firebase Cloud Functions, the flows that you want to explicitly deploy as callable functions, you use a separate syntax, and those will be deployed as Cloud Functions. But you can sort of have private flows, like as we were I was showing an example just here previously. So like if we want to call a flow within a flow. I don't know. I can't undo anything, but yeah. So you can have sort of a private functions, private flows that are not going to be deployed as Cloud Functions. Yeah.
Mm-hmm. Okay, cool. So I think one other thing that you mentioned in the introduction was that it's really easy to deploy Genkit. I don't know, do you call them applications? I mean, they're made up of flows, but then, the entire thing, is it called an application?
Yes. So I guess, there are a couple of different ways to deploy your kind of the app that you build. And with Firebase, it is obviously, we offer a whole suite of, products to host your apps. But like if you have static files, you can host your static files with Firebase hosting, and recently announced Firebase app hosting. And for Cloud Functions, like you can expose your flows as Cloud Functions. That and basically, like here we can see that we have our restaurant generator actually is defined as onFlow. So this onFlow comes from Firebase Functions plugin. So here we're using So and from here it is basically just as easy as you would run Firebase deploy, right? And it will just go deploy this code to Firebase. And if you have here in this app, I have a public folder that has an index file that I was using to render this page for all of my restaurants, right? So and I also have a functions folder with the sources. So and I'm this is where all my GenAI logic is with, well, not necessarily, but this is where all my Cloud Functions are, including my flows. The restaurant generator is a flow, is going to be deployed as a Cloud Function. And when I run Firebase deploy, it's going to go deploy these files to Firebase hosting, and my flows to as Cloud Functions, and they will just all work. And and the nice thing about actually, let me maybe show you here an example. I actually have. I should need to make this a little bigger. Okay. Okay. So I have a menu suggestion flow deployed to Cloud Functions. And here I can just make a curl request to this menu suggestion flow, So it is not open to the public. So I actually have to pass in the authorization headers. And let's see. Actually, no, I ran it in the background. So let's wait a second. It's gonna return our menu in a moment. It takes a second for cold start. Okay, here. This is it returned our banana themed. You can tell I love bananas. Banana themed menu. So here we have flambéed banana, Foster with coconut ice cream. This sounds amazing. So yeah, so this is actually running as a cloud function deployed as a cloud function for Firebase, and we're just passing it the input here. We're saying the input is going to be the bananas, and including the authorization and everything. So when it actually running in production, so here we actually see this cloud function deployed, and we can go and actually I have tracing and all the monitoring enabled for it. So and we can go to the cloud monitoring, and actually we can see all of the traces for our flow. And here, like this is the one that I just ran,
Nice.
and we see. And I'm actually like calling a flow within a flow here for whatever reason, just for demo purposes. And you can see their model calls to the Vertex models. I'm calling to like both the Gemini 1.5 Flash and Gemini 1.0 Pro, and actually there's an embedding model call in here as well. And yeah, you can go explore these things. And we're also, like, in addition to traces, we actually also logging metrics. So you can go look at. So I created a quick dashboard here. I think I should probably need to zoom out a little bit. So yeah, like we see see like flow requests, and we can see the breakdown. We have a menu suggestion flow and PDF QA flow breakdown that request counts. And we can look at different action calls as well. So we see, model calls, and here, like, if you want to, like, for example, manage the costs a little bit. Like if the model call actually costs you money, and you want to keep an eye on it, we also log, your input tokens and output tokens. So and you see like you can do like a breakdown by model, and you see that I'm calling to Gemini 1.5 Flash and Pro, and you can set up alerting. Like, for example, if you see a huge spike and you're worried that it's going to cost you too much, you can like kind of keep an eye through monitoring. Yeah, and you can go and explore all the different metrics through like Metrics Explorer.
Oh, nice. Yeah, because I was about to ask, where can I find those attribute names? Do I have to go into the Log Explorer and look at the log entries, but this is really amazing.
Yeah, and then you can see, like, some latencies and stuff. All are logged as well.
This is pretty cool. So what you showed us first, like in a Log Explorer, that looks very similar to what I can see in the Dev UI. Is that correct?
Yeah. So interesting question, because with Genkit we rely on Open Telemetry for our instrumentation of things, like including the traces and metrics and logging as well. So and with Open Telemetry, you can basically, it's up to you where you want to save your traces, right? So, and for, like, if you're running on Google Cloud has a very powerful, like, as you can see, suite of monitoring products. So we just basically, you can configure Genkit to send all of your traces and metrics and logs to cloud monitoring, and then you can see all of these things here. When you're running, like, in development mode, like, we're just attaching to the same Open Telemetry data and saving it to disk, so that the dev UI can pull up those traces and you can see them in the dev UI. So like, so these, I shut it down, but yeah. So the you get traces from disk. But also, like, additionally, you have an option when you're configuring Genkit in Genkit configuration here. You can say trace store, and you can say use Firebase Firestore as a trace store. What will happen is that so the Firebase plugin offers another way for you to save traces to Firestore. And when you will be running in production, those traces will be saved to Firestore, and you will be able to go. Actually, let me just run this quickly. So you'll be able to go to the dev UI. I have some compilation errors there now. I deleted some stuff, but yeah. So you'll be able to go to the dev UI and see those production traces loaded from Firestore. And this actually another thing that how we're treating traces with Genkit, right? So like traces within Genkit are not just for monitoring, right? So like we really see traces as data. So and those traces are incredibly powerful, and one of the things that allows us to do is to provide an evaluation framework. So evaluation, I guess it's a fancy term from the field of Gen AI or ML in general. That's basically how you would be evaluating your models or your performance. And it's getting also applied to Gen AI app building as well. But it is basically like, think of it as testing, right? So, but testing against like the logic that uses an LLM. So there's non-deterministic logic. So once you build your app, and when, for example, you're doing some kind of a maybe RAG within the app, right? So the retrieval augmented generation. So you're fetching additional context for the model from some kind of a vector store or database. So you're ultimately just asking an LLM to generate something for you. You would use evaluation to evaluate how well your retrieval actually works. For example, like is the retrieving working well? Is it providing the valuable context? Is the model generating the right answer given all that context? And actually, like maybe we can show a quick example. We actually have a cat evaluation sample within Genkit code base. You can find it on GitHub. So from here, I can just start this. And actually, like if you go into the README file, you will see like basically all the steps how to run this. But basically what you would do is you would run Genkit run flow setup. So this is like I've shown how to run flows and models through the dev UI, but you can also run them from the CLI. So
nice.
So this is a run flow. So basically you run the flow setup, and here we can actually go look at it. So we have a flow. Setup here. So this is our setup flow. It'll just go and actually it will run another flow, index PDF flow. It'll just go and index whatever the PDF files you give it, and our sample PDFs here is just something about cats, and then and cat adoption handbook, which is okay. So and so I already ran it. So we actually have we're using a local vector store here, and we actually go look at the contents of it.
Wow!
So
that's
like
just for those two PDF files.
Yes. So here we actually kind of index the cat adoption handbook PDF, and we see the embeddings here and the chunks of text that it indexed. And we can actually go, for example, what supplies do I need for my cat? Let's see if it's going to be able to answer this. Okay, yeah, there. Like it's supplies you need for the cat is all this stuff, and our our it was the PDF QA. PDF QA is index. Yeah, this is the flow, and actually this is how we're doing RAG, for example, right? So and we're doing we have a first class support for retrievers here. We're doing like retrieve documents using this retriever for this query, and then we have a RAG template. So basically, we're telling it to use this context and to generate an answer. And here we're making an LLM call to just answer given the context. And here we actually, you can provide additional safety settings. Yeah, so, but this is a kind of a simple RAG example, and but if we want to now say, how does my RAG pipeline flow perform against input, and here we can actually just generate some evaluation questions and say, I have a small subset here, just kind of to make it fast. But we would just generate this list of questions and what are typical cat behaviors, supplies I need, and all that stuff. And from here we can just say, go and run automatic evaluation. So actually, let me go grab the command from our handy README file, and I'm gonna run this evaluation. Yes, please run this.
So Pavel, while this is
Yep.
running, earlier you mentioned you chunked the PDF. Could you talk about why chunking is important?
Good question. Yeah. So I mean, if we look at the PDF, I mean the PDF is pretty large, right? So when the way vector store retrieval works is that so you would take the user query and you would generate embeddings. Like embeddings is just basically the fancy term for a vector representation of what we think this piece of text is talking about, right? So you would generate this embeddings vector for your input, and then you would use the vector store to search for relevant similar concepts to what you to your input, right? So and in your vector store you would have basically also your text that's relevant to answer the questions, and vector stores are able to kind of look up these things and return you these documents that you add as context. So if you just take this whole document as one big thing, and it's probably the vector store is going to say, well, this whole document is relevant to your question. It's going to return the whole document, and then you're going to give it to the LLM, right? So when we're doing retrieval, so for example, if we look at this PDF QA, right, we see here that the LLM gets your the whole context to answer the question from whatever vector store retrieved. So if the vector store will be giving you whole document back, the context window is just going to be just one giant document, which is probably with Gemini 1.5, it's probably going to work fine because it allows to a 1 million and the newer version 2 million context window, but it's probably going to cost you a lot because it is expensive. You're paying per token. So you actually want to optimize and actually only maybe return relevant pieces of text from your document. You don't need the whole thing. So by chunking your document, you're just basically splitting it up into maybe paragraphs and maybe more or less depending on the text that you have. And then so you will be indexing each chunk separately, and when you're doing retrieval, the vector store will only return these small chunks of text that are relevant to your answer, but to the question. So and finally result in a smaller LLM call, and it's smaller, faster, cheaper. So and basically it allows you to scale pretty much infinitely. So you can have huge number of documents indexed, and when you're asking your RAG flow to answer a question, it'll only be returning the relevant pieces, so you don't have to load all of that stuff into your context. Does that make sense?
Yeah, it does. Thank you.
Cool. Yeah. So and here we've seen our evaluation completed, and we can go to our evaluate tab in our developer UI. And here we see our previous runs for evaluations, and we can see here, like, these are all the questions that were asked, and we can click on these and actually see. So let me just show one quick thing. So in the configuration, we actually specify which evaluation metrics we want to use, right? So in here, we're evaluating for maliciousness and answer relevancy. So and here we see that there's answer relevancy and maliciousness metrics that we're evaluating against. And here we can see this was the question, and we can see the context. So this is what the vector store retrieved for us, and this was the output, right? So in here, it's actually saying it can't answer this question. And for example, we can see what supplies we need, and the output is, as we've seen before, all the supplies that you need. And you can actually drill into like these specific metrics, for example, answer relevancy and maliciousness. And here you can see the rationale from the evaluator saying, okay, like in this case, the output does not intend to harm, deceive, or exploit users, which is good. So maliciousness score is 0, and answer relevancy is pretty high, close to 1. So yeah, so evaluation kind of allows you to go and maybe like do this bulk evaluation of your retrieval or your Gen AI logic. It doesn't necessarily need to be retrieval against a fixed set of evaluation test questions, and it is really convenient.
I've got a quick follow-up question here. So if we look at the relevancy, I think if you scroll to the very bottom where we've got a high relevancy, and it said, here's why it's relevant, and it says cosine similarity. So am I correct in thinking that the evaluator will take the answer and compute embeddings for the answer, and then compute the embeddings for the question, and then compare how close they are?
Yes, exactly. And actually, like, we can, everything is traced in Genkit, so we can look at it at a trace here, and we can see for answer relevancy evaluator, like all these different test cases, we see that it actually computes the embeddings, right? So this is the computes embeddings and uses an LLM here to actually then also do evaluation. I don't remember, like, off the top of my head exactly the details of how it works, but yeah, your guess is correct. It is based on embeddings.
That's amazing. I'm tempted to say this is bananas. In a good way.
Yes.
All right, so this is amazing. Nohe, how are we doing with questions? I think I saw some questions on the live chat come through. Is there anything that we didn't answer yet?
So the first question that and this goes back to like maybe an hour ago. Do you plan to support text-to-speech and/or speech-to-text in Genkit? So I know Genkit has the media plugin. Maybe you could talk about like the types of media that supports.
Yes. So basically, like, if we look at the, it's the wrong one. If we look at the our generate function, let me find an example of generate function somewhere. Maybe somewhere here. So okay, so here we're making a generate call. So in the so our prompt here can be an arbitrary list of messages, and each message consists of parts, and each part is basically either a text part or media part. So like if we say a media, we can do like a URL and content type, and like a URL can be like a base 64 encoded
MP3
media. Yeah. So or maybe a URL to like a storage bucket, which is also totally fine. So and the output. So like for example, when we're looking at the LLM response here, it is also you can extract media from it, right? So and media can be pretty much anything as well. It can be either given a URL to maybe like a storage bucket that where output is written, or base 64 encoded media content. So the idea is that it really it's up to the model, right? So we've seen examples with Imagine, it takes text outputs and image, or like the Gemini 1.5 is full multimodal, so it actually can accept a mix of text and images and output text. And so it is just a matter of providing a model implementation that can understand, maybe an MP3 file as input, or produce text, or take text and produce an MP3 file as output. We don't have kind of a official plugins for this, but if you're interested in building one, we'll fully support you. Like we have we try to help out our community with building plugins, and like at the last time we checked, we have 18, I believe, community plugins. Whoa. With like for all sorts of models, and yeah. So the Genkit framework, like to answer the question, I would say the framework itself is ready to text to speech, speech to text. But we just I'm not aware of any plugins available just yet. So it's just a matter of someone taking that on and building the plugin.
And there's actually a follow-up question to this, and it's can you zoom in a little bit more on your font to make it a little bit bigger?
Oh,
there we go.
Just
might have to collapse the terminal a little bit.
Yeah.
Yeah. There we go. Hopefully that works.
Yeah.
And then the next question that I see is adding Genkit to an existing project. So let's say I had a Next.js app, Angular app, some other project. Do I have to run Genkit by itself, or can I just integrate it?
Yeah, so like think of Genkit as a library that you can add to any existing app. So yeah, like really, like when you're running Genkit, you are like with Genkit, JS. You're running just a Node.js app. With Genkit Go, you're just running a Go app. And we try to so all of the tooling integrations for like dev UI are really not intrusive. So like when you're running things in dev mode, like we create dev servers on the side. They're kind of really not getting in the way of your actual app. So you can easily add a Genkit to an existing app and actually still continue taking advantage of some of the dev tooling. Like you can even like attach the dev UI to an already running process if you want. It has an option to attach to a running process. Yeah, like we're really trying to not get in the way too much. But we obviously offer an easy path for you to, like, if you just starting out, like if you're just following that path, like it's really easy. But yeah, if you have an existing app, you can easily add Genkit to it as well.
What if I, if I want to call from the client? I mean, like we saw that we've got on-flow functions, so I can call them using HTTP. But is there, I guess, is there any support to make this, I don't know, like even easier from a mobile application, say?
Yes. Let's see. So yeah, I guess so. One thing to point out is I mentioned this before, but deployed Genkit flows are just like conform to callable function API. So you can actually use the Firebase callable functions SDK, client SDK, to call flows from wherever you want.
Mm-hmm.
So And here actually we have let's see if this is gonna run. Hopefully it will. Okay, yeah. So we have a little a little test app. So let's see. Hi. This is an Angular app that is talking to a flow, and the flow just basically implements like an agent that has access to tools. So let's see, like what's the weather today? I don't know what's the weather like. Let's see, and okay, so Toronto, and we say okay, and what date? Show me a date picker. And yeah,
Ooh.
and then
wow,
we
nice.
actually like
So not just generative AI, but generative UI.
Yes. So and basically like this kind of shows that you can just easily integrate. You build an. So this is an Angular app, and this date picker and this weather are just Angular components. So I'm streaming my agent responses from a flow and just rendering them here. And again, if the agent tells me to show a date picker, I'm just showing a date picker. If it's telling me to show a weather widget, it shows me a weather widget. So yeah, like you can totally do this fairly easily. There's actually like not too much code to go along with this. We're probably not going to have time to deep dive into it, but yeah, it's totally possible. This like I probably built this within a few hours. It didn't take me that long.
And that's part of the sample folder in the repository.
It's almost like it is. I pushed it to a branch, but I intend to merge it in. So yeah, it will be in the samples folder. Yes.
Awesome. Okay, so folks can see it by following you on the repository. That's amazing.
So
cool. Nohe, any other questions?
Oh yeah, there's a ton. So one of the other questions that came up, and I don't know if we're qualified to answer this, but there's a few questions about overlap with the Vercel AI SDK. I personally don't know anything about the Vercel AI SDK. I don't know if you all have any thoughts or knowledge on that SDK.
Yeah, I know a little bit about the Vercel AI SDK. Well, a little bit, not a ton. So the one thing I know that it actually works really well with Node.js and Node.js like runtimes. I think it supports more than just Node.js. So yeah, it has like some model abstractions and an ability to stream as well. So with Genkit, we kind of focusing on a lot more. Like like as you've seen, like we really go deep into tooling. To help you, really build end to end, like with. So you're actually just building the whole back end, not just UI. So like Genkit offers and focuses like on a lot more than just building a UI with streaming, and actually like you can use Genkit with Node.js as well. So I guess like if you really like zoom in on like building UIs with like Gen AI UIs, there's some overlap there. But yeah, Genkit offers a lot more with from like observability and evaluation, production deployment, and all that stuff.
Excellent. And then, some more feedback coming in. There's a lot of like for the videos, more community videos like this. One other question that came up is how do you add and retrieve metadata in the RAG? So I guess someone wants to see a little bit about retrievers and indexers, and we did touch on that briefly previously. Could you show us a retriever?
Yes. So let's see, where are we? So this is our cat sample, right?
Mm-hmm.
Yes. So yeah, this is indexing, right? So for example, depending on what you're using as a retriever, which vector store you're using, you might have a retriever or not. Sorry, you might have an indexer or not. But like for example, our local file-based vector store that is used for development here, it has an indexer, and you can just basically add things to it. And when you're indexing, for example, here, like so, we're loading the PDF from text, we're chunking it, and then we're just creating these documents, right? So here we're using document from text, and the second parameter is just metadata, right? So and you can add any additional metadata that you want in here, and it will get stored as part of the document. Again, like it depends on the on the vector store. Like for example, the in this restaurant generator that we've been showing, it is using the Firestore vector store, and our here, like we have a recommender that just basically goes and retrieves these restaurants from Firestore vector store. And so Firestore will actually like take your Firestore document and just like put that as metadata. So like it actually very easy to work with those. Like you just basically get your original Firestore document as metadata. So if you want to store additional metadata about the document, just put it in your Firestore document, and it will be stored there as well.
Would you, specifically for Firestore, where you can store the embeddings in a vector field, which we launched, just a couple of weeks ago, I'm curious about chunking, right? So let's assume that we've got Firestore documents that are literally text documents, right? So let's assume that we write a text editor on each of those Firestore documents are a text, and it could contain like a very large chunk of text. So for computing the embeddings, you would obviously compute the embeddings for the entire document. But what about chunking? What you said a while ago about the costs of computing embeddings generating something based on a large chunk of text might be expensive. So how would you handle that?
I mean, like I guess in the same way. So like the cost of computing and embedding, like computing as embedding is much cheaper than doing a full LLM call, right? Yep. So like here let's see if I can undo this far enough so that actually this compiles. Is this going to compile now? Oh, no, the restaurant is gone. I think it just needs this const restaurant LLM response output. I think that's all it really needs, or maybe not. Whatever. So yeah. So here we're just writing to Firestore collection, right? So and in this case, like in case of restaurants, like it just already happens that these descriptions are kind of a paragraph size. They're perfect size, right? So we don't need to do extra chunking. But like let's assume that you kind of maybe these descriptions were actually much longer, and you might want to do some splitting. So what you would do is like you basically take this description and I don't have the chunking library installed in this app, but you would like go and chunk these. So you basically get chunks, and then you just basically say for each chunk separately, you would write a separate document to Firestore. Right. So and here like you would generate embedding not for the full description, but for the chunk. Right. So and yeah. So this is like how you would typically split things up and make more manageable.
Okay, sounds cool.
And then you showed that you use Firebase deploy to deploy the cloud function or the flows to Firebase cloud host, not cloud hosting, Firebase functions. When you run that Firebase deploy, do you automatically overwrite the existing functions, or do they stay persistent in that project?
So it actually, like, Firebase deploy will ask you. So it will like for deploying functions, what you want to do with existing functions. So yeah, so the cloud functions for Firebase, the CLI deploy process is going to confirm things with you.
Yeah. Sometimes I just
And you
blindly
all,
click enter and hope for the best.
The default is actually, so I think that the question that it asks, like, if the when you're running deploy on a separate code base and you have existing functions, it will going to say, like, do you want to delete the other functions? And it defaults to no.
Okay.
So, like, if you don't change it to yes, you're good.
can you also specify additional attributes? For example, if you want to specify the amount of memory for one of your flows, how can you do that?
Yes. So basically, this on flow for deploying for cloud functions for Firebase actually takes the, like, I believe HTTP options. So you actually have a concurrency, cores, CPU, memory, max, min instances. So this is like the straight up from the Firebase cloud functions for Firebase callable function options. So you can
Nice.
set and override any of these, including enforce app check, which is you probably really want to do if you're kind of making a public endpoint, maybe like you're calling it from your app. You want to make sure that it is does app attestation to kind of avoid abuse. So if you're not familiar with app check, I really recommend to take a look at it. It's really useful anti-abuse mechanism.
Yeah. Absolutely enable app check for your applications, folks. All right, so we are already over 1 hour, and I think I think we answered most of the questions. I still have a ton of things that I would want to ask, and I think we talked about this before we started the live stream, and we joked around and said there's no way how we can get through all of the stuff that you wanted to show, and I think we only made it halfway in, if at all. So would you be happy to come on again, or is there any other place where people can find out more about Genkit?
Yeah, like I'll be happy to come onto the show again and continue talking about Genkit. As you can tell, I love talking. Hard to stop me. So yeah, and we'll probably be putting out a lot, like more videos for more deep dives into these subjects. Like, as you've seen, like, the list of subjects within Genkit is pretty long. So we're probably going to be doing videos for with deep dives into those. So yeah, keep an eye out for those. So, like, probably through like whenever those come out, like we might probably advertise those through regular Firebase channels. So yeah.
I've got one small ask. Can you go to the Firebase Genkit repository so that we can show people the discussions forum so that they know where to ask questions, because I think that is probably the easiest way to get in touch with the team, right?
Yes. So basically, on GitHub, Firebase/Genkit is our GitHub repository, and we have the discussions forum here enabled. So yeah, like, if you have any questions, please feel free to ask them here. We're keeping an eye on those and trying to stay active. So yeah, and like, if you look at the code, like some of the samples we have, the Angular JS with the agent samples is gonna drop in here. But if you look at, we have some what we're calling test apps. The cat eval sample is here, like we have been seeing with the evaluation flow. You can try out is here, and we have a bunch of other examples, like including, like, if you want to deploy your app as with an Express server, like adding Genkit to an existing app, or adding it to an Express server, and a bunch more here. Some of them are messy, but the one that I'm mentioning are probably good enough. Yeah.
Amazing. That's pretty cool. Yeah. So I'm working on a video that will hopefully come out pretty soon, but I know that you're working on a couple of really deep dive videos that go into how does it really work behind the scenes, right? So I'm super excited about these, and we will publish them on the YouTube channel in a dedicated playlist for Genkit. So folks, if you're not subscribed to the Firebase YouTube channel, don't forget to do that. And bookmark the discussions forum so you can ask your questions. For any questions that we didn't answer in this live stream, we will open a discussion on the discussion forum, basically for all of them, and then the team can go in and provide answers. Awesome. Noe, is there anything else that we need to cover today?
Probably not today, but maybe in a future live stream we could. I think if you are enjoying these live streams and you want to see different topics covered, leave a comment down below once the video is fully published, and maybe that's how we can generate an itinerary of what we will talk about next.
Absolutely. Or we can, we can ask the model or write a flow.
Yeah.
All right. Let's wrap it up. Folks, thanks for coming. Thanks for asking questions. Thanks for staying to the very end and looking at the numbers. And it seems like most people stayed to the very end. That's amazing. Thanks, Pavel, for coming on. Thanks for sharing insights on Genkit and answering all our questions and the questions from the audience. And with that, happy coding wherever you are on the planet. Have a good rest of your day.
Bye.
Bye-bye.